For biodiversity's sake, and also just for wildfire risk prevention as climate change continues and things get hotter and droughts get more intense, without these controlled burns that kind of clear out a lot of that built up fuel, there's a higher risk of more intense and severe wildfires if they do start. They've been doing prescribed burns for longer out on the eastern shore and more of the grasslands, but they had started doing it more in western Maryland. They didn't have anyone doing long-term vegetation monitoring to see how effective they were being and help target future burns. Why I'm doing the research I'm doing is to kind of see the effectiveness in this area of the country, the central Appalachian region. Fire has naturally occurred in landscapes forever. As people have kind of moved into these areas, it's been suppressed, which has allowed plant species that aren't adapted to fire move in and alter the landscape and community composition, which changes the habitat that's available for other plants and animals and changes soil conditions and the canopy and makes it a lot more closed in so light isn't getting to the bottom. At each of these flags that are just spaced every 10 meters, we lay out a big measuring tape. There's these little gauges. These ones in particular, my dad 3D printed. Along the tape, you measure how many dead woody things cross over the tape that fit into each of these notches. There are calculations that you can make to kind of get an estimate of the fuel loading should an ignition occur across the area that you have measured. I write it down and then I go back and put it in a spreadsheet, and then I have an R script set up to do all of the calculating for me. The goal is to create a model that would allow us to predict what's down here for land managers in the central Appalachian region to use, get an idea of what sort of fuel loads they could expect, what sort of plant communities they could expect in the understory, to at least give them a starting point for management.